Way back in Unit 1, when we talked about step and work complexity, we said that we would love to find algorithms that have the same work complexity as the serial algorithm, but have a smaller step complexity. Reduce would be a good example here, or scan. But if we said we can't do that, sometimes we would be willing to accept more work if it gets us fewer steps. And that's what we're going to do here. But how? This is not intuitive, or at least it isn't for most people, and it certainly wasn't for me when I learned this material. Hillis and Steele first expressed skepticism they could improve on quadratic work, but then concluded, I'm quoting from their paper, essentially, we overlooked the power of having many processors working on the problem at once. So at a high level, here's what we're going to do. On every node, we start by knowing the node that's one hop away. That's the next pointer in blue. So on the next iteration, we can visit our next pointer's next pointer and get 2 hops away. And then on the next iteration, we can get to 3 hops away, and so on. So that's what I'm showing here when I say straightforward approach. As we increase the number of iterations, we're also increasing the number of hops away. But that's the wrong way to think about it. If we just did it that way, we'd be repeating a lot of work that the nodes down the chain are doing, and we would have quadratic complexity work. Instead, after the first iteration, we have each node knowing the node that is 2 hops away. So let's say we're interested in this node and we know that we're pointing to node X here. Well, normally what we do is we take the red pointer here and then change our red pointer to be red pointer plus blue pointer. So we'd be moving from knowing the node 2 hops away to the node knowing 3 hops away. But look, X also knows the node that is 2 hops away. So I know the node that's 2 hops away, X knows the node that's 2 hops away. So on the second iteration, we can leverage the work that X already did on its first iteration to get a pointer that is now 4 hops away. So we can go red, then red, to set our new red pointer here to be the chum of the chum. Now we're going to have a pointer to a node that's 4 hops away, which also has a pointer to a node that's 4 hops away. And so the next iteration will have a pointer that's 8 hops away, and so on. So now instead of going 1, 2, 3, 4, we're now going 1, 2, 4, 8. So for n iterations, as a function of n, how many steps is this going to take?